pi over 12 questions. I don't know if you noticed on your pie plate when you finished it, but the gap between 0 and 30 degrees is bigger than the gap between 30 and 45. And it would kind of, maybe you felt like, oh, it'd be kind of nice if they were all equal. Well, that's what we're going to do today. We are going to fill in the lines that we're missing and add the pi over 12 family. And we're going to be able to do all of this without our calculator, using our previous knowledge of the pie plate and the new formulas that we just learned, which were our alpha plus beta formulas from yesterday. So we have 6 new formulas, 2 for sine, 2 for cos, and 2 for tan. And with those formulas, we're going to be able to figure out the exact value of each of these. So here's the strategy. The strategy is to use the family members that you know, pi over 3, pi over 4, and pi over 6. And what I've done in brackets there is I've written them with a new denominator of pi over 12. And then add or subtract them to get whichever pi over 12 you're looking for. I'm also going to hand back your pie plates so that you can use them while we do this. And this unit, you will be able to use these pie plates on your test to confirm your answers. Okay. So now I want you to look at those and see if you can figure out ways that you could make and I have one here, colorful pizza pie without a name on it. Okay, so how would I get pi over 12? I hope you could see that you could get it with 4 pi over 12 minus 3 pi over 12. Can you see that 4 pi over 12 minus 3 pi over 12 would be 1 pi over 12? And maybe notice that it also could work if you chose 3 pi over 12 minus 2 pi over 12. There's more than one way to get pi over 12, and we're going to notice that in these questions. So we would start off by writing cos of pi over 12 equals cos of 4 pi over 12 minus 3 pi over 12. And then when we reduce those, we notice both of those are on our unit circle. And the first one's going to be our alpha, and the second one is going to be our beta. Then we go to our formula sheet and say, what does our cos alpha minus beta formula look like? It's cos alpha cos beta plus sine alpha sine beta. And this time we know alpha and we know beta, so we can substitute them into the question. And now we just have to get these values from our pie plate. So it's nice, you'll be able to use your pie plate. I would suggest trying to do them from memory, because you'll need to have it memorized for your final exam. But you have your pie plate to double check that you got the values right. And then we do have to write our answer as a single fraction in the end. So we're going to multiply our fractions, multiply the tops, multiply the bottoms. Can you see that you're going to get a common denominator of 4? And then you would end up with a root 2 plus a root 6 all over 4. Oh, so our next question was in degrees. And sine of 75 degrees, I wrote above here what it's equal to in radians. It is a pi over 12 question. But 75, if it's in degrees, you just have to think, what are two things on your unit circle that would add or subtract to give you 75? And again, there's more than one right answer. Like I could have chosen 120 degrees minus 45 degrees to make 75 as well. But I think 30 plus 45 is probably the most obvious. Then, you know what your alpha is, you know what your beta is, you look on your formula sheet, what's my sine alpha plus beta formula? Sine alpha cos beta plus cos alpha sine beta. And once again, all of these are on your unit circle. We get a common denominator, and we get a root 6, a root 2, and a 4 again. And this is going to be a common theme for all of your pi over 12 questions with sine and cosine. You will always have a root 2. Sometimes it'll be positive, sometimes it'll be negative. You will always have a root 6. Sometimes it'll be positive, sometimes it'll be negative. And it will always be over 4. So if you'd done a bunch of these, you'd start to recognize this as a pattern. So what we're going to do next is I am going to hand out a piece of scrap paper to everyone. there because it's big, but I can bring it to you. Yeah, the bigger pie plates I left over on the wall over there. So what I'd like you to do on this scrap paper, once you get it, is to take things that are on your pie plate and make them over, like, for example, if you took 5 pi over 6, 5 pi over 6 is equal to 10 pi over 12. Take all of the values, short one. Take all of the values on your pie plate, change them to pi over 12, because what we're going to try to do next is we're going to try to find the exact value of cos of 17 pi over 12. And before we do that, we are going to try to find what two things add or subtract to get 17 pi over 12. Now, the challenge to this is once you find one, you'll call me over to verify it, and once I've written it up on the board, it is no longer available. You have to find a different one. There are an infinite amount of right answers that add or subtract to 17 pi over 12, but they're not that easy to find. So once you find one, I write it up there, and then that one's taken off. And then you have to find, if you haven't found one yet, you have to find a different one. Well, we're not going to take that much time, but we'll probably get 6 or 7, or 5 or 6 or 7 up there. So now we have got 6 different ones, and I'm about to ask you, what do they all have in common? But if you tell me, well, they all equal 17 pi over 6, that's obvious, okay? Yes, all 6 of those will equal, no, sorry, not 17 pi over 6, 17 pi over 12. All 6 of those equal 17 pi over 12. If it's really easy to see that if you change this to, like this last blue one, well, this is 27 pi over 12 minus 10 pi over 12. That obviously will make 17 pi over 12. But the next thing I want you to do is there's something else that all 6 of these have in common, and it's going to be the hint or the key for us to figure out all of our pi over 12 stuff. What do you notice?
The denominator of 4.
Each one of them, yes, look at that. There's always a pi over 4. There doesn't have to be a pi over 6. There doesn't have to be a pi over 3. But every single one of them had a pi over 4. So if I go to my pie plate and I go, well, let's see if this works. Let's see if I pick a random pi over 4. I'm going to go all the way around past once. And then I'm going to go, say, to this one. Okay? This one over here, 3 pi over 4. What if I chose 11 pi over 4? That's some random pi over 4 family. I could change that by multiplying by 3 to 33 pi over 12. Obviously, that's too much to make 17. How much would you have to subtract off 33 to get to 17? You'd have to subtract 16. Is that correct? So 16, if I subtracted 16 pi over 12, this would equal 17 pi over 12. Now, I started with a random pi over 4. If you start with a random pi over 4 and you reduce the other one that works, look at that, that's on your pie plate. It will always work to give you one that's on your pie plate. So any pi over 12 question, we can go to where we were about to solve cos of 17 pi over 12. You can always start with any pi over 4 family and then just figure out what would work. And that's what makes these questions extreme. If you know that step, these questions become extremely easy. Because the hardest thing is finding the two things that work. But if you know you have to use a pi over 4, all of a sudden it becomes easy. So I decided to start with 21 pi over 12. And once I wrote 21 pi over 12, it was like, well, it's obvious I have to subtract 4 to get to 17. Then, once you reduce them, they will always be two things on your pi plate. And then it's just a matter of plugging it into the proper formula and using your unit circle or your pi plate to get the values. Remember that in some quadrants, things are negative. So in quadrant 4, sine of 7 pi over 4 will be negative root 2 over 2. And then once you simplify it, this time you get a root 2, a minus root 6, and all over 4. And sometimes on tests or final exams, there's a part B to a question like this, that after you figured out cos of 17 pi over 12, they say, well, could you figure out secant of 17 pi over 12? And then you would just have to take your answer and do the reciprocal. Because if cos was root 2 minus root 6 over 4, then secant would be the flip of that, 4 over root 2 minus root 6. There was one final exam that just asked, what is secant of, I don't know if it was 17 pi over 12, doesn't really matter. And so many students left it blank on the exam, it was worth 4 marks. Because they were like, if you don't think to first find cos of 17 pi over 12, then there's no way that you're going to think to figure out secant of 17 pi over 12. So after that exam, they changed the exams to always have a part A and a part B, where they first asked the cos, And then they make part B a 1-mark question and say, well, if you figured out cos, could you figure out C? And then students had better marks as a result. Here's another one. I'm going to give you one more question from an old exam. So on an old exam, they had determined the exact value of 4 cos 11 pi over 12. And it was interesting on this exam as well, is students could do cos of 11 pi over 12, but putting a 4 in front, it was like, I have to leave this blank now. Now really, I'm hopeful most of you have seen the number 4 before. That 4 is just 4 times this. So if we figure out cos of 11 pi over 12 first, and what I would have done is I would have just said, okay, I'm just going to start with pi over 4, because I know I need a pi over 4. Pi over 4 is 3 pi over 12. What do I have to do to get to 11? I would have to add 8. That's pretty straightforward. Then when I reduce these, it always works out that they're both on our pi plate. We can then use our formula for cos is cos cos minus sine sine. Get the values from your pi plate. And simplify, and you get that cos of 11 pi over 12 is negative root 2 minus root 6 over 4, which means if you multiplied both sides by 4, you would get 4 cos of 11 pi over 12 would just be negative root 2 minus root 6. And I hope that when you get to your final exam, and I mean this year you're not writing a provincial one, but we've been doing these kind of problem-solving questions. What happens when there's something new? Don't get scared by it. Don't let it throw you off. Just say, okay, what do I know how to do? I know how to do the cos of 11 pi over 12. Having that 4 in front, although it looked different, isn't too crazy. Figure out what I know, then in the end, multiply both sides by 4, and we get our answer. Okay? These pi over 12 questions, once you realize that you have to use a pi over 4 family and the alpha plus beta formulas, they're very predictable. And so most students who study this love these questions because it's like I can get 3 out of 3 every single time on these questions because they're straightforward and they don't change. I'd like you to circle number 7